Alright, so a bit of a different topic, and this is pretty much the last video on light. This is the idea of light dispersing when it passes through certain types of things, like raindrops or prisms. And then the white light then breaks up into its component wavelengths, which we typically call colors. So this is an example of that. Here we've got a diagram over here, and then here we have an actual real picture of this happening. So let's really quick zoom in on, well, first thing you notice, white light comes in, bam, refracts through the prism, comes out the other side, and because of the angles of the refraction, it splits up into its component colors, because different colors, different wavelengths, different frequencies, these are all different wavelengths and different frequencies, they bend, they refract slightly different angles. So if you can get them to bend enough through, like say, a prism, then they break up into their different wavelengths and you can see them separate from each other. So this white beam actually has all of these colors in it. You just can't tell when it's a white beam. You have to break them up. All right, a couple things I want to point out before we move on to the next slide. First, anytime that light strikes a surface and refracts, almost any time you're also going to get a little bit of reflection. Now, I'm not totally sure that I've pointed that out prior to this video, but I'm pointing it out to you now. When a light ray strikes like say a glass surface, and we talk about it refracting into the surface, a little bit is also going to reflect, and that's what you see here. So a light ray comes in, part of it reflects off of that surface, and part of it refracts into the surface. So it's worth noting that that happens almost all the time. You usually get a partial reflection and a partial refraction of the light ray. All right. Now, if we zoom in a little bit more on this, I want to show you, if you look really close, you can see that in here, you can already see the colors breaking apart a little bit. You've got some red on the top and you've got some blue on the bottom. So that's to point out that the light starts to break up into its component wavelengths, into its component frequencies. It starts to happen at this first phase. They start to break apart. It becomes much more pronounced here at the second phase, but it starts to happen here. So they like to ask questions about this a lot on the IGCSE exam, where they'll show you a diagram, and one diagram has them breaking up only on this face, but they actually start to break up on this face, and you can even see that right there if you look really close on this image. You can see that there's blue on the bottom and red on the top. So obviously on this picture that they drew, they showed it much more dramatically. But yeah, it starts to break apart at this face, and then it becomes much more pronounced at that face. All right, so let's talk about this a little bit more. Dispersion is defined as the breaking apart of white light into its component colors. More accurately, we would call those the component frequencies. All right, so different frequencies of light are different colors as we perceive them. There's a set of frequencies that we might call blue. There's several different shades of blue, so that would be more than one frequency, but each of those shades of blue would be just one frequency. Now, if we had light that was a single frequency, exactly only one frequency, then that would be monochromatic light. Monochromatic means only one exact frequency. All right. You do not want to say that monochromatic is one color. All right. Color is not specific enough. You have to use the word frequency. It's one frequency of light. Color covers several different frequencies, as we were just mentioning with blue. Blue could be a lot of different shades. But if we have exactly one frequency, then that is called monochromatic light. And typically, monochromatic light comes from a laser. All right. Last thing for this. The order of the colors. All right, so when white light disperses in a prism, this is that same picture again. It breaks up into its component parts, and those colors are typically given 7 different names. I guess recently they decided to get rid of the indigo, but I believe it's still there for the IGCSE syllabus, so we're going to go ahead and learn it, just so you know. Alright, so there's a little mnemonic device for remembering this, and it's called Roy G. Biv. It's like somebody's name, Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. And that starts at the wavelength, the frequency that bends the least is red, and then the frequency that bends the most is violet. All right. So if you were thinking about the spectrum, the electromagnetic spectrum, visible light is one portion of that spectrum. And so if this ray happened to have a little bit of extra radiation that we can't see, so say it was coming from the sun, it probably has some ultraviolet and some infrared in there, as well as just these colored lights, so as well as the visible light. So if we were able to see it, we would see some infrared over here in this region beyond the red, and we would see some ultraviolet over here in this region beyond the violet. If we were able to see them, we might see those. So ultraviolet light would be over in this part, and infrared light would be up here, if it were possible to see them. So red bends the least, violet bends the most, and that's why it splits up in exactly this way. Red, starting with red, and you can see the colors there. Red, orange in there, yellow, green, there's the blue, indigo is right in this region, and there's violet. Alright, that's it for Dispersion of Light. Nice short video. Thanks for watching, and we'll see you next time.